Hi, my name is Katie Oseek, and today we'll be talking about group homomorphism and group isomorphism. What is a group? A group consists of a set and an operation. Operation may be like addition or multiplication. It has to be closed under that operation. It also has to be associative. Go back to middle school, associative property. It also has to have an identity. If you operate it with any other element of the set, you will get that same element. You have to have inverses. When you operate it with an element, you should get the identity. Those are the four properties of a group. The integers with addition make a group, or the reals with multiplication also make a group. Okay, so that's a group. So what is a homomorphism? Basically a function, and it preserves the group operation. So, a function, it'll map from one set to another. But what happens is it preserves the operation. So say your first group, your domain group, its operation was addition. And your codomain, its operation was multiplication. And your function was called f. If you took f of a plus b, that should equal f of a times f of b. That's a homomorphism. An isomorphism is very similar, only it preserves the group operation, but also it's a bijection. That means it's one-to-one, which means every output has one input, and it's onto, which means every element of the codomain is mapped to by an element of the domain. One-to-one is a very good way of thinking of it. So why does that matter? If there exists an isomorphism or a homomorphism between two groups, you can say that they're isomorphic or homomorphic. Yeah, groups that are isomorphic are essentially equal in the eyes of an abstract algebraist. Even though the elements or even the operation are completely different, the groups will act the same way, which is pretty crazy. You define this function, and it's basically equivalence. Super rad. What about homomorphism? Homomorphism. Hard word. It's slightly less, and I don't want to say less useful, but they're similar because it's not a bijection between them, but you can define a homomorphism between them. What ends up happening is your domain and codomain don't have to be the same size anymore, so you end up getting what we call an n-to-1 mapping. If you had a 5-to-1 mapping, that means that 5 elements in your domain would map to 1 element in your codomain. What you end up getting is a more simple version of your domain. And that will be helpful if your domain is super complicated. You can find a homomorphic image of that, and it's slightly easier. It's simpler, but it's easier to work with. And that's what makes it so rad. It's super useful. Anyway, that is group isomorphism and group homomorphism in a nutshell.